everyone, and welcome back to these lecture slides on writing in economics. I'm Carola Binder, and this is the second lecture in a series. So if you haven't already, feel free to go find the first lecture on writing in economics, which was about principles of clear and coherent writing. What we're going to talk about today is writing about numbers and also making a table and writing about a table. So let's start right in. Just to let you know, the content of these slides is originally from the Chicago Guide to Writing About Numbers by Jane E. Miller, as it was summarized by Paul Dudenheffer. And I put a link to Dudenheffer's book in the first lecture. Okay, so when you're writing about numbers, the first thing to do is make sure that you establish the context. So imagine you're writing the intro of a paper. It would do no good to report that 1 million teenagers dropped out of high school in 2006. Okay, the reader doesn't really know what to make of that. How does that number compare with, say, numbers in other years? Is 2006, are you trying to say that 2006 was an especially bad year? How does it compare to the total population of high school students? So is that, I don't know, is that 1% of high school students? Is that 10%? Tell us something like that. And then what other context might be needed to fully understand the number? So is this high relative to what we see in other countries, for example? So you want to establish the context for the numbers rather than just giving the reader some number that they're not really going to know what to make of. The second thing you need to do in talking about numbers is report and interpret the numbers. Okay, so when you write about your findings, if you're doing some empirical research, you should just do more than just report the numbers. So don't just say, I ran a regression of y on x and the coefficient estimate was 2. Okay, tell us what that 2 means, and especially what it means with respect to your thesis or research question. So you can say, my hypothesis was that the coefficient would be positive, and indeed it is, and it's important that the coefficient was greater than 1 for this reason. Okay, so you interpret what your number means. That includes telling us the relevant units, and it may include linking it with the research question that you should have explicitly explained before doing the empirical analysis. Third, use magnitudes that make sense or are easy to comprehend. Okay, so here's an example. Say you write that the US national debt is over $12 trillion. Okay, most people, me included, have trouble comprehending that number. It's just too large. Okay, but if you talk about it in per capita terms, almost $40,000 a person, that number is a little easier to grasp. The fourth thing when you're writing about numbers, if you're talking about an association, so a relationship between two variables, you always want to specify both the direction and the magnitude. Suppose you find that education is associated with voting. Okay, usually you say associated with when you're trying to avoid making a claim about causality that might not be supported. But so you might just find that two variables are correlated, and you say that they're associated with each other. Yes, but in what direction? So you want to tell us, are people more likely to vote as their education goes up or less likely? So are these variables positively or negatively correlated? And you also want to specify the magnitude of the association. So in this example, by how much does the likelihood of voting increase or decrease as education increases by a certain amount? So you could say, for each additional year of education, the probability that a person votes increases by 2 percentage points. Or you might say college graduates compared to high school graduates are X percent more likely to vote. Okay, and again, you would want to put that in context. So you could say college graduates, and I'm making up these numbers, 50% of college graduates and 40% of high school graduates vote. So you can, it's easy for the reader to compare. Okay, so that was writing about numbers. A related thing is writing about and making tables. In most empirical economics papers, you're typically going to have two common types of papers. There's tables of descriptive statistics or summary statistics, and there's tables presenting regression results. So summary statistics are usually going to include the mean, the standard deviation, and the number of observations of key variables that you're analyzing, possibly separately for different groups. So you might, for two different countries, summarize provide the mean and the standard deviation of their GDP and their inflation rate, say, or you might do for two different time periods for the US, summarize the mean and standard deviation of their inflation rate and other variables. Okay. If you're conducting a survey, you're usually going to provide a table of summary statistics for the respondents in your survey, all the demographic information that you might have about your respondents. So tables presenting regression results, of course, you'll only have those in a paper in which you have done some econometric analysis, including a regression. But that's going to be the second main type of paper of table in an empirical paper. So a table has certain main parts. First is a table number. So every table in your paper should have a number, and the tables should be numbered consecutively throughout the document. Depending on what type of, whether you're writing in Microsoft Word or in LaTeX or some other program, the tables might automatically get numbered in order, but if you're manually typing the table numbers and you later rearrange your tables, make sure that you update the numbers. And they should also be numbered in the order that you refer to them in the paper. So if a certain table is called table 1, that needs to be the first table you mention in the text of your paper. Next is a title. Usually, so you might have something that says table 1 and then the title of the paper. The title of the table. The title should be brief but descriptive and not a complete sentence. So for example, it might say, percentage of women aged 45 to 60 who smoke by educational attainment, or effective class size on student achievement, OLS regression results, or summary of income data from survey in rural Georgia, 1920 to 1945. Those are some examples of titles. You wouldn't want a title that just said regression results, okay? It needs to be more informative than that. You need to imagine maybe somebody wants to share the table from your paper on Twitter or something, and people are going to look at the table without reading your whole entire paper, and they still want to be able to have a sense of what it's about. Okay. Tables also have column heads. So every column of information has a word or phrase at the top that identifies what information is going in that column. Now, I know sometimes you do need to abbreviate things, but you want to try to do as good of a job as you can of making it readable. So your variables in Stata might have some complicated names that only you, the researcher, understand what they mean. But when it comes time to making your table, you want to change those from whatever they're named in Stata or whatever your program is to things that sound more like English words that people could basically read and understand. Then the very leftmost column in a table is called the stub. So those say what's contained in each row. Okay, so when you look at the stub and the column heads, then you know what's in each cell of the table. The body is all of the rest of the table. So it's all the columns to the right of the stub and below the column heads. That is usually going to have, usually it's going to be numbers. It's going to have the data that you're displaying in your table. Okay, so that wasn't all. There's a few more parts of a table. A really important part that sometimes gets forgotten are the footnotes. So at the bottom of the table, you're going to see something like notes or sources, and it talks about what exactly is in the table. So there might be a source note identifying the source of the data using the table. or if for some reason you've reproduced a table from another paper, another published work, and of course you need to have the right kind of permissions and decide it appropriately, but you would put that information in the source note. There's also going to be general notes and specific notes about what's in the table. So for a regression table, you will include in your notes something about if you have significant stars in the table, you want a key. So say, 1 asterisk means you have statistical significance at the 10% value or something like that. You're going to explain this is an OLS regression, what's the dependent variable, what are the independent variables, explain any abbreviations you had to use, explain the time period of the data, the source of the data, just tell the reader what's in the table, even if they're not going to read your whole paper. Imagine somebody's just looking at the table. Can they read the footnote, look at the table, and understand what's in there? Okay. Finally, there's rules in a table. Those are just the lines, the horizontal lines usually, that separate the table into parts. So usually only horizontal rules are used. Most publishers don't actually allow you to have vertical lines between the columns in your tables. Let's look at an example. This is from a working paper that I just wrote a few days ago called Coronavirus Fears and Macroeconomic Expectations. And I conducted an online survey of households on March 5th and 6th, and I asked them about their concerns about the COVID-19 or coronavirus outbreak that we're currently in the middle of. And then I also asked them about their macroeconomic expectations, so their expectations of unemployment and inflation. And I did this survey just a few days after the Federal Reserve had announced an emergency rate cut of 50 basis points. And so part of the survey was to see whether people were aware of the rate cut and whether it was calming their concerns, but also what these concerns were going to do to their inflation expectations, which is really important to central banks. So this table here, table 3 of my paper, you see it has a table number 3, and it has a title, Macroeconomic Expectations by Concerns about Coronavirus Effects on Economy. Okay, I asked the respondents, how concerned are you about the effects of coronavirus on the economy? And I split them up into those that said they were not concerned, that they were somewhat concerned, and that they were very concerned. So you can tell what type of table this is. It's a table of descriptive statistics. It's not a regression table. And here you have the column heads, not concerned, somewhat concerned, and very concerned. So in the first column, I'm going to have information about those respondents who said they're not concerned about the effects of coronavirus on the US economy. Now, here's the stubs. So for each group of these respondents, I'm summarizing what fraction of them believe that there'll be less unemployment next year, what fraction of them believe there'll be more unemployment next year, what is the expected rate of inflation that they say they have for next year, and what fraction of them give an inflation forecast that's a multiple of 5 percentage points. The reason I have that is because in another paper, I show that consumers who are really uncertain tend to report multiples of 5 percentage points for their inflation forecasts. So I wanted to see which of these groups of consumers is most uncertain about inflation. Okay, so what you can see is that for the respondents who are not concerned about coronavirus, 17% of them think there'll be less unemployment next year. 19% think there'll be more unemployment. They expect inflation of about 2% for next year. And 40% of them gave me an inflation forecast that's a multiple of 5. Now, if we go over to the respondents who are somewhat concerned or very concerned, far fewer of them expect lower unemployment next year. More of them think that unemployment is going to rise. So we see the more that they're worried about coronavirus, the more they're also worried that unemployment is going to rise. And they also think inflation is going to be higher next year. This is the somewhat surprising part. It's not too surprising that people who are concerned about the effects on the economy expect higher unemployment. But it was, before I did this survey, it was sort of ambiguous whether people would think that the coronavirus was going to raise inflation or lower inflation. I think the financial markets would have treated it as something that would lower inflation if it was an adverse aggregate demand shock. But a lot of consumers seem to think that, anytime there's bad news, that means inflation is going to be higher. And looking at the bottom row here, these consumers who are more concerned about coronavirus also seem to be slightly more uncertain in that more of them are giving multiple of 5 inflation forecasts. So that's how to interpret the content of the table. And then the table has a footnote here that explains what's in the table. And it's not particularly long in this case, and I didn't take the data from anywhere else, so I didn't have to cite a source of the data because it was my own, from my own survey. Now, when you present information in a table, so whenever there's a table in your paper, there's at least 2 expectations that you need to fulfill. The first is that you explicitly introduce the table. So every table that's in your paper needs to be pointed out in your text. So in the main part of your paper, you need to mention that the table exists and indicate its general content. So that might just be a single sentence. Table 1 shows the incomes earned by full-time workers in the United States. Or in Table 1, I present the results of the 3 regressions that explore the relationship between income and education. The second thing is, in your narrative, so in your text, identify the main points made by the data in the table, the points that most closely correspond to your research question. Okay, so don't just tell the readers, see Table 1 to see my regression results. You need to tell them what it shows. For example, Table 1 reveals significant characteristics of our sample that could affect our results. 1/3 of women in the sample had less than a high school education, nearly 2/3 were unmarried, and exactly 1/2 had at least 1 child under 3. Or, as expected, the coefficient on education is, in every regression, significant and positive. So you might also wish to point out any counterintuitive results or results that are especially large or small. But you don't need to comment on every piece of information in a table. So if you ran a regression of a dependent variable of interest on an independent variable of interest and a bunch of control variables, you don't necessarily need to talk about the coefficient that you found on each and every control variable. You might say that the coefficients on the control variables were as expected. You might say, if there was one that was surprising, not the sign you would expect, talk about that. But you don't need to talk through each and every one if there's a lot. And then if there's a particular coefficient of interest in a regression table, you want to talk about the number that they should actually be interested in. So as seen in column 1, the coefficient on education is 0.583 and is statistically significant at the 5% level. And then, as we talked about before, when you give us a number, you also talk about, you put it in context. What does the magnitude mean? What does it say about your research question? Is this coefficient, say, larger or smaller than what others in the literature have found in a similar regression, and so on. Here. So let's go back to that example table that I showed you from my own recent paper. Here's where I started talking about that table in the paper. As shown in Table 3, so you see I've introduced that there is a Table 3, concerns about coronavirus are associated with more pessimistic unemployment expectations and higher inflation expectations. So that's a summary of what's in the table. Then I'm going to point out some key numbers. For example, mean inflation expectations are 2% for unconcerned consumers and 3.4% for very concerned consumers. Then I'm going to contextualize that a bit. This is consistent with recent research showing that consumer pessimism is associated with higher inflation expectations. Okay, so that was the end of today's lecture on writing about numbers and writing about tables. And then next time we're going to talk about writing a paper, writing key parts of the paper, including the introduction and the conclusion. All right, thanks for listening. Bye.